Okay, I'm going to do a full curve sketching example, going through all the steps that I outlined in the notes. So we're asked to sketch a curve of this function f of x. First thing that will be helpful is let's expand the numerator so that we can take an easier derivative. Okay. Once we do that expansion, we're going to get that that's x cubed plus x squared minus 9x minus 9. It's going to be all over 3 still, but I'm going to write this as 1/3 at the front to make our derivative easy. Our first step says set the first derivative equal to 0 to be able to test for the critical points. So let's take the first derivative, f prime of x. It's going to be 1/3 times 3x squared plus 2x minus 9. Now multiply that 1/3 in, and we're going to have x squared plus 2/3 x minus 3. So we have to set this equal to 0 to find those values that could be our local maximum or local minimum points. When we do that and set this equal to 0, we can see that sometimes you can factor this. However, in this case, we need to use the quadratic formula. Our x results, when we plug this into the quadratic formula, should be negative 2.097 and x equals 1.431. Those are the 2 x values once you plug it into the formula. So these are our local maximum or local minimum points. We need to use an interval table to figure out if they're the maximum or the minimum. So we set up our intervals from negative infinity to infinity. So we have negative infinity to negative 2.097, negative 2.097 to 1.431, and 1.431 to infinity. Okay? And remember that we have to set f prime of x equal to 0. Don't use the original function, use your first derivative here. And choose points that make it really easy to tell if it's positive or negative. Okay, so between negative infinity and negative 2, I can choose something really big, like even negative 10 works. Between this interval, always choose 0 if you can, and then I'll just do 10 again here, because you'll see how this really helps. So we're going to plug negative 10 into f prime of x, and we're going to have negative 10 squared, so 100, minus this value minus another value. You can see that that's a really large positive number minus smaller numbers is going to stay positive. Plug 0 in, we're going to have 0 plus 0 minus 3. This is going to be negative. And then plug 10 in again, we have the same result as a really large positive number plus a positive number minus something small. This will be positive. Meaning our function is increasing, then decreasing, then increasing. So negative 2.097 is a max because it increases then decreases, and 1.431 is a minimum because it decreases then increases. That's our first 2 steps in the problem. The next step says we need to set the second derivative equal to 0 to find the inflection points. So let's take the second derivative here, prime of x. We're going to have 2x plus 2 over 3. Set that equal to 0, and we're going to have 0 equals 2x plus 2 over 3. So x equals negative 1 over 3. Okay? And now this is a possible inflection point. Remember, it's only a possible inflection point. We have to check, once again, an interval table to make sure that it is. It could bounce at the graph and it could not be an inflection point, so we need to verify this. So we do it again, negative infinity to negative 1/3, and then negative 1/3 to infinity. And we're checking with f prime of x. Okay. Choose something here, we can do negative 10 again, and this goes over 0, so I can choose 0. Negative 10 here, plugged in the formula gives us negative 20, plus a small fraction will be negative, and then 0 plugged in will just give us a positive value there. Okay? So this is negative and a positive, so here we have concave down, and here we have concave up. Okay, so negative 1/3 is in fact an inflection point. Our next step is to get the y values for those 3 points. So I have them here as 1.683, negative 5.634, and negative 1.975. Okay, so that's 1, 2, 3 critical points that we can use to plug into our graph. The other things we can look at are our x-intercepts and y-intercepts. From this original equation, we know that we have negative 3, 0, negative 1, 0, and 3, 0 as our x-intercepts. And if we plug 0 in for x to find our y, we're going to have 3 times 1 times negative 3 equals negative 9 over 3, which is negative 3. So 0, negative 3 is our y-intercept. Okay? This means that we have 3, 4, 5, 6, 7 points that we can plug in to finally get our sketch. Okay? To ensure that you have the right concavity, you should start at an inflection point when you're graphing these equations. Let me plug in. Okay, so I have all my points here graphed. I'm going to start at the inflection point and show that everything on this side is concave down, and start again here and show that everything on this side is concave up. Okay. And that's 7 points to give us a sketch of our curve.